All right, guys, your notes are going to be over rotations. So we've had 4 types of transformations. We got translation, reflection, and our third one is rotations. Vocabulary. These notes will be rather short, so you'll be glad about that. Make sure they're focused so you guys can see. Center of rotation. So remember we said that a reflection was a FL flip, a translation is an SL slide, a rotation is a turn. The point, the image turned around. The center of rotation in 8th grade will always be the origin. It will always be 0, 0. Okay? Rotation. So again, we need to know what a rotation is. Even though I've already told you, we're still going to add it in our notes. A rotation is a transformation, so it's one type. It's one of those 4 that turns. It turns a given image around a fixed point. So we talked about a translation that when you slide a figure, it stays facing the same position, so it preserves orientation, right? A translation also preserves congruence, meaning it stays the exact same size and the exact same shape. A reflection, when you flip it, it stays the same shape and same size. However, reflection does not preserve orientation because the letters are not facing the same way when you flip it. Now let's think about a rotation. When you rotate a figure, is it going to stay the same shape, same size? It will. It preserves congruence. What about when you turn it, when you rotate it? Will it stay facing the same way? Is it in the same orientation? No, it is not. It does not preserve orientation unless it only preserves orientation unless it's a 360, which means it's right back where it started. Unless, that's important. That's the only type of rotation that preserves orientation, okay? And then now we're going to have some rules. So let me ask you this. A skateboarder, when they do a trick, how many degrees do they do when they turn all the way around? Hopefully you said 360 degrees, a full circle. Okay. Now the rules are for clockwise, and then we have counterclockwise rules. So clockwise goes like a clock, 12, 3, 6, 9, right? So it rotates this way. Counterclockwise rotates opposite of the clock. So it's going to go this way. Oh, let me put it on the outside like I did this one. Okay. Now it doesn't matter about a 360 degrees and 180. It doesn't matter counterclockwise or clockwise. So that's why I'm writing these in the middle. But the rule for the two are XY XY. So it's going to be right where it started. I'm going to slide that up so you can see it. The rule for 180, again, it doesn't matter clockwise or counter. All we know is when we see 180, the both values go opposite. So it does not matter. Direction does not matter for these two. All right. The ones that do matter are 90 degrees. So 90 degrees clockwise starts off as XY, and the rule, Y will be moved to the front, X will be moved to the back and become opposite. For we already have 180, and then the other degree would be 270 degrees. Now 90 degrees, 270 degrees, let's say clockwise. Again, we know all ordered pairs start out X comma Y. The rule here is Y goes to the front and becomes opposite. Notice I'm not saying negative, because what if it's already negative? What's going to happen to this? That value will become positive, so it doesn't mean it's negative. All right? Now let's talk about 90 degrees counterclockwise. We know it starts off as XY, right? The rule is negative Y, X, or opposite, not negative. I just said that. I wasn't going to call it negative. Then we have 270 degrees counterclockwise. And that will become Y opposite X. Now, in looking at these rules, hopefully you notice that 90 degree clockwise and 270 degree counterclockwise, they have the exact same rule, and vice versa. I'm just going to draw quadrants, 4 quadrants here. This is quadrant 1, quadrant 2. This is quadrant 3 down here. And this is quadrant 4 here. The most important thing that we need to know is that a rotation, 90 degrees, is 1 turn, which is 1 quadrant. 180 would be 2 turns, or 2 quadrants moved. 270 would be how many? 3 turns. And what would be 360? 4 turns. Yes. So let's say that we had an object. Let's say we had this heart in quadrant 1. And I said rotate the heart 90 degrees clockwise. Clockwise goes this way. 90 degrees is 1 turn. So that means that the heart would end up in quadrant 2. If I said rotated 180 degrees, that's 2 rotations. 1, 2. That's clockwise. If I say 180 counterclockwise, 1, 2. Regardless, it still ended up in the same quadrant. So that's why direction doesn't matter for 180 degrees. 270 is 3 turns. So let's say 270 clockwise. Clockwise. 1, 2, 3. It ends up in quadrant 2. If I say 270 counterclockwise, I would go this way, which is 1, 2, 3. 360. 1, 2, 3, 4. I end up back where I started. If I go the opposite direction, counterclockwise, 1, 2, 3, 4. I still end up in the same direction. That is it for notes.